Hello, my name is Joshua. I'm from Group 4 and today I'm gonna talk about gradation and fineness modulus of fine aggregate. Fineness modulus is an index that represents the mean size of the particles in aggregates. The higher the value of fineness modulus is, the coarser the aggregate is. The fineness modulus doesn't define grading curve, as curve and different gradings can have similar value of fineness modulus. Many agencies use fineness modulus variation as a convenient way of keeping quality history data on uniformity of particle size distribution of aggregate production and delivery. Some companies use fineness modulus as a limit and require that aggregate to be processed according to that limit. Fineness modulus is a significant factor to consider when designing concrete mixes, especially in specifying the proportion of fine aggregates to be added in the mixture. Typically, sand having a fineness modulus exceeding 3.2 will be unsuitable for making a satisfactory concrete. Now, this is the tools that is required to do this experiment. So we have a set of shifts, a digital scale, a motorized dynamic shift checker, a pen, and an oven. Now, this is the material that we're gonna use. This is a sand, a fine aggregate, basically. Now, the procedure of this practicum first is to stack the shifts from number 4, 8, 16, 30, 50, 100, 200, and pen. After we stack the shift, we're gonna put the set of shifts on the motorized dynamic shift checker. After that, we're gonna take the dry fine aggregate, the sand, and put it in the shift number 4. After we put the sand in the shift number 4, we're gonna close the shift and then we're gonna turn the motorized dynamic shift checker on for 15 minutes. After 15 minutes, we're gonna weigh the retained weight of fine aggregate on each shift as well as the aggregates left on the pen. After we weigh the fine aggregate, we're gonna get this data. So this is the retained weight in each shift and this is the percentage of it. Now we're gonna need to calculate the cumulative data of each retained weight. So here is the cumulative data from the retained weight of fine aggregates that is left in each shift. So we have 0.3 grams, 2.3 grams, which simply is gonna add 0.3 to 2 and 2 and 2.3 to 42.2 and so on. And after that, we're gonna need to look for the percentage of retained weight. We simply just gonna use this formula, the retained weight divided by total weight times 100 to get this data. After we get this data, we're gonna search for the best percentage of this. So we simply just gonna use this formula, 100 minus the retained percentage. So we're gonna get this data. After we get all this data, we're gonna sum the cumulative retained percentage, and so we're gonna sum this and we're gonna get this 477.9. And this is important to find the fineness modulus, as the fineness modulus is simply this divided by 100. So after we get all that, we can plot the data into this graph. So we can see this is the pass percentage and this is the diameter of the sieve in millimeter. Now, from this experiment, it is determined that the fineness modulus of the fine aggregates is 4.779. Now, referring to Shaddy's claim that aggregate with value exceeding 3.2 is unsuitable in making a satisfactory concrete, it can be concluded that the fine aggregate test is unsuitable for construction use. Now, the error factor in this experiment is human inaccuracy while taking readings may contribute to the abnormalities in the data. Fine particles might get stuck into the sieve, resulting in the difference of fine aggregate's initial weight to its weight after sieving. Now that is all. Thank you very much.